All right, hey guys, welcome. I'm on slide 16 right now, and it's right after class. And look at how many of you guys are still working on this. Maybe you're working on this during your second block class. Hopefully, you're not blowing off your second block asynchronous class, but it is what it is. Maybe you're on here. Some people are near finishing, other people are catching up a little bit, which is cool. So if you're over here on these slides, you're just sort of realizing that any kind of these two equations here, or these are going to be the ones we're going to work with right now. As you saw when you graphed both of those, they both pass through a common point, right? The common point being 2, 1. Okay, so in this part here, our knowledge of equivalent equations, okay? We're going to try to solve for this using something called elimination. And that means we want to eliminate a variable. I'll get to that later. But the idea of this is we want to find two new lines. Well, maybe just one new line. I don't know. Two new lines. So we want to adjust this to an equivalent equation. Okay, how can we do that? Can we multiply both sides by 3, multiply both sides by 4? Well, I don't know. But if we do that to both sides, we find an equivalent equation here, maybe an equivalent equation here. What you should have seen in previous slides is that those equivalent equations should pass through the same common points between these two lines here, okay, right? So the idea is they're still going to pass through our point we're looking for, okay? If we're trying to solve this system, so maybe switch to another slide here. We're trying to solve, right, in this assignment here, this is your introduction to this, is we're trying to solve this system using something called the elimination method, okay? And that might mean adjusting these equations so that we can kind of add them together and eliminate a variable, okay? That's my sort of introduction we'll kind of go into in a second here, all right? So check this out. Going to this in slide 17 here. Solving algebraically, part 1. Finding an equation with only one y. Okay, only one y. So we want to eliminate x somehow. Okay, so let's check this out here. Here is our original system of equations, right there and right there. One multiple of red is this. Okay, is this here. Negative 3x minus 6y equals to 12. Add this new red and our original blue and write the new equation into the box below. Okay, so here, let's just do this real quick and then we'll maybe talk about it a little bit more in a second. This is the multiplied red. What do we multiply both sides of the original red by? I kind of talked about this during the lesson earlier. But here, we multiplied by what this negative 3 is going to tell us. 3 times negative 3 is negative 3x. 2 times negative 3 is negative 6. And we got the y there, so it's negative 6y. Negative 3 times 4 is negative 12. Okay, so we're allowed to, right? In math, you're allowed to multiply one side of the equation as long as you multiply the other side of the equation, okay? If I have two sides of an equation, multiply one by one value, and I multiply the same by the same value, right? My equation will still remain balanced, okay? Right? And with equations start being balanced, and I multiply one side, I got to multiply by the other, and then the result is they're still the same, okay? So here, what you should be seeing is I can add these two together. Negative 3x plus 3x, that's a 0, okay? That's a 0. And negative 6y plus y, well, I'm at negative 6, I'm adding 1y to it. That's going to bring me to negative 5y, okay, negative 5y. So negative 6y plus positive 1y, we'll still have a negative amount of y's, be negative 5y's left there, okay? And that's going to be equal to negative 12 plus 7. Well, negative 12 is greater absolute value, right? So we're more negative here. Negative 12, we add 7 to it. Well, 12 minus 7 is 5, so this is going to be negative. So this is going to be negative 5 here, okay? So that's what our equation would look like. And what happened? We eliminated x. Now we have an equation with only one y. So this is what I would put down for this slide right here, okay? So let me do it on another sheet of paper because this is ultimately what you want to work towards, which is how do you solve this system using the elimination method? What do? Well, I'm going to try to eliminate x, okay? Step 1. And let me show it to you like this. Try to eliminate x. Okay, and how am I going to do that? Okay, and what I want to do is by multiplying the top equation by negative 3. Okay, negative 3. So I might put that in green so you can see it a little more clearly, by negative 3. Okay, so hey, you're sitting down to solve this system of equations right here. Oh, I got x. I got only one x up here. X plus 2y equals 4. 3x plus y equals 7. We assume they intersect at some common point, right? Because that's usually what lines, if I have two lines, they're usually going to intersect at a common point on a graph. So I want to solve this by adding the two equations together. So what I'm going to do before I add the two equations together is, right, what they did right here is I found an equivalent equation, right? An equivalent equation. So multiplying the top equation by negative 3 to form an equivalent equation that can eliminate the 3x, okay? We want to eliminate that 3x in the second equation when we ultimately add equations together. So elimination has to do with multiplying one of your equations, both sides, and then adding the two equations together. So the goal is to eliminate one of the variables when we add both equations together. Okay, I've written a lot, but let's see it go down here. Let's see it go down here. Okay, so if I multiply this top equation, remember, I multiply one side of my, so they're equal, they're balanced, multiply one side of the equations by -3, or at least should be going down that way, -3, I'd have to multiply, my equations wouldn't be balanced unless I multiply the other side by -3, okay, other side by -3, and then they're balanced here, okay? So this involves knowing the distributive property. Hopefully you've learned that in middle school. Again, we don't have time to dedicate a whole lesson to distributive property, so hopefully you're picking it on up here. The idea is that we're changing this red equation, okay, this red equation to -3 times by x is -3x. -3 plus 2y is -6y. And then here, this -3 right here times by 4, because remember, we're multiplying both sides by -3. -3 times 4 is -12. Okay, -12. So that here is a way we can get an equivalent equation. Over here, we don't need to actually multiply this equation at all to eliminate, because if I move this 3x plus y equal to 7 over here, I'm going to eliminate in a second. That's what you did right here, right? So there was really just two steps. Step one, multiply that top equation by, well, I chose -3 because I wanted to eliminate the 3x in the bottom equation. Okay, so that's sort of give you a little hint how to do this. Step two, add those two, add those two equivalent equation, the multiplied red to the original blue, and you'll get something. You'll find an equation with only one y, and that's very easy to solve. Y is going to have to equal 1, right? Positive 1. Remember, 2, 1 was our solution for this one. It all connects together. Very complicated here. Okay, so the one thing that I didn't show, right? So try to eliminate, multiply the top equation by -3 to find an equivalent equation that would eliminate the 3x when we add both equations together. So step 2, maybe I'll put this here. Step 2, add equations together, right? The multiplied red to the original blue. And I just figured I'd move this down here because now we can, right, eliminate, right? This is called eliminating. Eliminates. Okay, add the two together, -3x plus 3x. Well, that's just going to equal 0, okay? -6y plus y, that's -5y. -12 plus 7 is -5, okay? So now, to eliminate, okay, what we can do is solve for y. Okay, we'll solve for y. So I'm going to do to both sides. I'm going to divide both sides by -5. Divide this side by -5. And y, right, because -5y's, if we split that -5 ways, that's just going to be left with 1y. -5 divided by -5, anything divided by itself is 1. So we get y here equal to -5 divided by -5 is +1. Okay, step 3, it looks like they're going to go over that with you in the next slide, which is going to be slide 18. Okay, so now that I have this here, right, simplify to get y equals number. When we eliminated one variable from that, we get that. Multiply that equation. Write a simplified version of your new equation. Well, you should just say y equals 1. Okay, y equals 1 for this one. And the idea is you just divided both sides by -5. Okay, so explain your thinking. -5y equals to -5. If I divide -5y by -5, my answer is 1. Sorry, yeah, is 1y, right? It's just y. And if I divide the other side by -5, I get 1, right? -5 divided by -5 equals 1. Therefore, if I divide the whole equation, -5y equals -5 by 5, my simplified equivalent equation, right? It's equivalent if we're dividing both sides by 5. It goes through that 0.21. Simplified equivalent equation is y equals 1, right? -5y divided by -5, -5 divided by -5. Result on the left side's y, result on the right side is -1. Right? Not this complicated. A little bit tricky here. So hopefully you get that, you submit, and you're good to go there. People still working. People kind of trudging through here. It's okay. It's okay if you're waiting for the video. If you're watching the video anyways here. All right, so we got this here. This is what you should have gotten right here. Now we need to find an equation for x. It says, hey, talk with your group. We don't have time for that yet this year. But we need to find an equation with only one x here, okay? So we solve for y, we get this. So how do we figure out what x has got to equal? Well, we know what y is here. So what we're going to do is we're going to substitute 1 for y into an equation, right? One of the original equations. It could really be any of these equations here. Any equivalent equation, hopefully the original equation, in case you made a mistake on the equivalent equations here. But substitute 1 for y into an equation and solve for x. Okay, so let's take our red equation maybe. I'll take x plus 2y is equal to 4. Let's check it out. X plus 2y is equal to 4. Substitute 1 into it. Okay, 1 for y. Okay, so we're going to put that 1 right in here. And I'm going to get x plus 2 times by 1 is equal to 4. X plus 2 equals 4. Subtract both sides by 2. And x equals 2. So I get 2, 1 as my solution to my system. Great, because I knew that by graphing earlier here, right? Graphing can be very fast if your points go through a lattice point. You can see that there's 2, 1 for your answer. But you could also just, if you're very quick solving these algebraically, you can get this super quickly using elimination. This isn't a very slow method at all, right? This looks like a lot of work now, but it's not a lot of work after you get practice with it, okay? So 2, 1 is my solution here. Okay, so here, hopefully you put in your answer here, but hopefully find an equation only 1 x. All right, substitute 1 for y into either equation. Let's do red, which is the x plus 2y equal to 4, right? We see a red equation right here. And then we could do this maybe. You can do this. This actually puts an equation for you here. So x plus 2 times y. So hopefully I see some work on this one. You turn it in here. And then solve for it, okay? I should say, and then solve. So there we go. And then this is with simplified. 2 times 1 is 2. So x plus 2 equals 4. Okay, and then maybe we subtract 2 from this side, and we take away 2 from this side. To keep the equations balanced, I subtract 2 from one side, got to subtract 2 from the other, and then I get x equal to 2. And then I have x. There we go. Then I have x. Hit submit. Okay, slide 20. All right, we're getting closer to third block here, so I got to bounce a little pretty soon here. Let's see here. We might be able to find another multiple of an equation to eliminate y. So this is just like another way of solving. This is going to go through another one here, it looks like, here to get rid of y. What's happening here? Original system, another multiple. Okay, one way we might be able to find another multiple of an equation to eliminate y. Example the original equations, write a new equation in which we will eliminate y. Okay, so here you're getting some practice doing this a little differently, okay? So this is, we eliminated x originally. Let's maybe look at, write a new equation in max box that will eliminate y. So maybe this is having you think outside the box here. Let me write down your original equations right here. Again, up top. This is what you're doing on slide 20, okay, which is going to be x plus 2y equal to 4. And then we got here 3x plus y is equal to 7. And I'd like to see your bright ideas right now. Like, I'd love to see that right now. But the question is, here, that's what do we do? What do we do to eliminate x? They're showing it to you. We multiply both sides by -3, the top equation. What would I have to do to eliminate y? Okay. Well, maybe you're doing this. Like, this is the way I would do it here. This is 2y right here. This is positive 1y. So if I do 2y minus 2y, that would get rid of the y's here. So How would I make this negative 2y right here? Well, I would multiply both sides by negative 2. And then my equation would become this, right? Negative 6y minus 2y equal to negative 14. And yeah, right? Because this is negative 2 times 7. That's negative 14 here. And now if I just bring this other equation over here, x plus 2y, x plus 2y equal to 4, now I can eliminate. Okay, now I can eliminate. Check this one out here. This should have been, why did I put negative 6? Oh, yeah, right, negative 6x is what it should have been here. Sorry. Negative 2 times 3x is negative 6x. Negative 2 times by y. Remember, you're distributing here. Distributive property of multiplication over addition. Negative 2y and then negative 14 here. So now I can eliminate. I can add them together. X minus 6x, well, that's negative 5x. And here, positive 2y minus 2y, well, that's just going to be 0y. We eliminated y. 4 minus 14 is negative 10. Okay, negative 10 here. So just asking you how you can do that. And what I did is I changed the blue equation right here. I changed this equivalent equation would have been 6x plus negative 6x. Sorry, negative 6x. Plus, minus 2y equals negative 14. Explain your thinking. I multiplied both sides of original blue equation by negative 2. Now I can eliminate the 2x on the red equation when I add the equations together. Okay, so elimination kind of works by multiply one equation by a certain amount, and then you add the two equations together, and you should eliminate a variable. Like, that's the goal. So that's the tricky thing, is to think about, what do I need to multiply by to eliminate a variable here, okay? So let's check out, see here. This is showing this here. What do you got here? Y equals 1. Part 2b. Let's see. Part 2a is that. I don't know if I didn't read that right or not here. But anyways, substitution. We can take our value y equals 1 and substituting either of these equations and solve for the second. This happens when when I explain this method is similar. What the heck? Y equals 1. Yeah. Okay, so this is just solving for the x variable. Next steps on the left show to use y equals 1 to find the mixing x. So I explained this, how this method and then method on the previous screen are similar and different. I don't understand this question. I guess it's no different. I would say it's no different. I don't know. Put a question mark down. That's fine. I'm not sure. I'm interested to see if I'm going to miss that here. Okay, debrief here. These are our objectives here. Tell me what you think about it. I know this elimination thing might be a little bit confusing. We'll get some practice on it during tomorrow's asynchronous classwork and homework. Let's try one more. Create additional red and blue lines. Ooh, multiples. Add the red and blue line equations to create new purple lines. Well, let's check it out here. Oh, yeah, let's do it here. Right? Just get some practice with this. What's equivalent to x plus y equals 7? Well, what about negative 2x minus 2y? Equal to negative 14. Yeah, there we go. We're on red right there. There's another one. So try to fill this out. Fill this out. 3 lines here. 3 lines here that are equivalent to blue lines. And then get some purple lines. Add them together. Get clever with it, okay? You got to get used to this here. Multiplying equations and then adding the 2 separate equations in your system together to ultimately, right? How would you solve this algebraically? 5, 2. And then, maybe I'll have you solve this, right? X plus y equals 7. Negative x plus 2y equals negative 1. This is actually easy to solve through substitution. Sorry, through elimination. If I do x plus y equals 7, add it together, I would eliminate x. I would get y plus 2y is 3y. 7 minus 1 is 6. So 3y equals 6. And that's why y equals 2. 3y, and it's going through here. Okay, hopefully you enjoyed this one. This is sort of an investigation and introduction to elimination. We're going to get more practice on this as the week goes along here, because you'll get an asynchronous lesson on this tomorrow. Elimination method, starting with those 2 equations. What do I do? How can I practice that? That's tomorrow. Email me if you have any questions. Have a great day. Bye.